Welcome to the IT Career Energizer podcast. For anyone who wants to build and grow a career in IT, develop and improve your strengths and skills, be inspired and motivated by the successes of others, manage your career progression, and achieve your IT career goals. And now, your host, Phil Burgess.
Welcome to episode 270 of the IT Career Energizer podcast. My guest on today's show is IBM Chief Technology Officer for AI Strategy, an IBM Fellow and a Master Inventor in the IBM Data and AI group. He is also chair of the Data and AI Technical Team, the working group of IBM's technical executives in the division. As well as being the founder and co-founder of several large-scale initiatives including AI databases, he co-founded the IEEE Data Engineering Workgroup on Self-Managing Database Systems. He has also authored 4 books and more than 30 papers, and his books have been translated into Chinese, Japanese, and Spanish. So welcome to the IT Career Energizer podcast, Sam Lightstone.
Hi, Phil. Thank you very much for having me.
Sam, could you maybe give us a bit of an insight into your current role with IBM? I understand that you're Chief Technology Officer for AI Strategy.
Yeah, that's right. It's an exciting role that I started really just a few months ago, and in that role, I'm basically the chief geek, so to speak, the leading technical officer who's looking at our AI strategy across the company, which includes a huge array of products, as well as looking at elements of our marketing and our services, some of the non-technical bits as well. Before that, I was CTO for data, looking at a different portion of the portfolio around data storage and databases and big data systems. So I've had an opportunity to see different pieces of the IT space and play a role in shaping it, so to speak.
Right. And what was the attraction for this sort of change of role towards AI?
Well, I had already been working in AI in my previous role as CTO for data, so it wasn't a big leap. I would say more a change of emphasis. For me, it was an exciting and attractive change because in my previous role, I was looking at data technologies within one division of IBM. In this new role, I have the privilege and the luxury of really looking at technology across the entire company. And AI is really a transformative technology. I hesitate to call it a technology because it's many different technologies, but it's a domain of technologies that is really going to transform the IT space, and it's going to transform society as we know it, actually. So I'm excited to spend more of my time on it.
Right. I mean, to me, AI is very much a label at the moment. It doesn't necessarily translate into anything directly, in my opinion anyway. Are you able to sort of maybe give us a bit of color around what you believe AI to be?
Oh, okay. Yeah, I'd love to do that. So actually, there's a whole collection of terms that people throw around. AI is kind of the umbrella terminology, but you'll also hear people talk about data science and machine learning, deep learning. These are all subsets of the larger domain that we call AI. I would say that at its core, really what's interesting about AI is it's not what people think it is. People imagine it as being computers that think. Actually, yes. AI is not about that. It may one day aspire to be that and become that, but actually, from a philosophical perspective, from a methodological perspective, what AI is actually is a fundamental change in how we program computers. That's the interesting bit. For the last 50 years, we program computers by telling them what to do, by programming instructions. If, then, else, call this function, call that function, and you had to code everything explicitly. And that whole paradigm of programming computers in that way is fundamentally limited by the ability of a programmer to express their thoughts, to express their logic in some programming language that we call code. Now, what's interesting about AI is it's this fundamental shift from that old paradigm of programming by instructions to a new paradigm where we're programming by showing the computer examples. And when we say examples, we mean examples in digital data. So we show the computer data sets. Sometimes those can be numbers, or it could be passages of text, or it could be images or video, but it's all digitized examples. And from these digital examples of data, we teach the computer how to do something. So it's a big paradigm shift from programming by instruction to programming by example. And it's not as mysterious as you might think. So, for example, you may think of, I think many of us, if you've studied a bit of higher maths, you may have learned about linear regression. And if you're not familiar with linear regression, it's simply given an XY scatter plot, a bunch of dots on a graph. Draw a straight line that comes as close to the dots as possible. If you could only draw one line, what is the one line that most closely matches the dots? And that's called linear regression. So linear regression is sort of the most basic, the most fundamental of all the machine learning algorithms. And when you learn it in school, they don't even tell you it's a machine learning algorithm, right? But if you think about it, what you're really doing is you have some data points on this XY scatter plot. And from those data points, those examples, the machine is going to look at that data and learn through an algorithm, in other words, through a procedural process to figure out how it can best organize this line to match the dots as closely as possible. So when you think about it that way, you go, oh, well, that doesn't sound like artificial intelligence. but actually, that's the kind of thing we're talking about. However, the algorithms get much more complicated and much more sophisticated than simple linear regression. So there's a whole range of these algorithms. But actually, at the end of the day, when you distill the whole thing, the big change is programming through example versus the old paradigm of programming by explicit instructions.
Indeed. Great. Well, that's a fantastic explanation. Thank you for that, Sam. That really helps.
Okay.
Sam, can you share with us a career tip, one that the audience may not be aware of and perhaps should be?
A career tip for people working in IT.
Indeed, yes.
Yeah. Well, let me share with you one thought. If you really want to go, of course, it depends what you want to do in your career. But for those who want to have a career that is vaguely similar to mine, where I've worked in product development and I've worked in a large company, and I think this tip applies to smaller companies as well. One of the challenges that people have, if you really want to go all the way, is you have to be an innovator. You have to be a founder, and that's true if you're creating your own company as a startup. But that's true if you're in a bigger company. Bigger companies make new technologies too, of course, and somebody had to have the idea. So where do these ideas come from? Well, they come from individuals who take the initiative and bring ideas forward and push them and advance them and get them done. So the question is, how do you do that? That's easy to say. How to do. So there's lots. There's probably books that could be written on this. I just want to give one tip. Which is, it's very important to convince people. And in order to convince people that you've got a good idea, whether it's a startup company or it's a new idea in an existing company, you have to convince people. And the best way to do that is to help people visualize it. So if you can make a prototype of your brand new idea, that's the most compelling. But actually, you don't have to go that far. You just have to be able to help them visualize it. So a mock-up is often sufficient, even if it's just done in PowerPoint. But help people really visualize the idea that you have in mind. And once they visualize it and they can understand the big idea in a visual way, either by actually seeing it in action or seeing your mock-up, it goes a long way in getting your ideas funded, getting believers behind you, and making great things happen. So stick to this idea of having either a prototype or at least a mock-up of your idea to show people. Just talking about something and having ideas on paper, having a business plan, actually, it's not nearly enough.
Indeed, yes. So to me, that all sort of falls into the sort of the bucket around communication skills and how you actually manage to communicate an idea or a benefit of whatever it is that you're working on.
Yeah, absolutely. You asked me for one tip. If I had the luxury of a second tip, which is closely related, and I think you're sort of leading me in that direction. The second tip would be don't underestimate the criticality of communication skills, the ability to
Yes,
express in language and inspire people with your idea. Make sure they clearly understand it and they're excited about it. It's not enough for them to understand it; they got to be excited. And if you're excited about it, and you can convey that excitement, and you can convince them that it's a useful thing for the world, it's just your odds of success are multiplied tremendously.
they are, exactly. We may well come back to that later. But if we move on to the next area. So, Sam, can you tell us about your worst career moment and what you learned from that experience?
Wow. Well, first of all, I would say that any good career has many bad moments. if you
Yes.
you have to, because if you don't, if you you know if you're not really pushing it, you're not going to succeed. And if you are pushing it, then you'll have failures. So, I've got a long list of these things, long list of these failures, but the failures hopefully are far outweighed by the successes. But I'll just pick one. Um, uh, I remember it was a number of years ago, we were developing some cutting edge in memory analytics technology. We were all very, very excited about this new technology that was going to be, you know, more than 10 times faster at computing analytic results than the previous generation of technology. And we also were designing it to be very simple to use. Everyone had lots of enthusiasm, lots of excitement. And it was early days of the technology. We had brought the technology to market, but it was still somewhat new technology, and we were still ramping it up in scale. And the phone, metaphorically speaking, the phone rang, and we had an opportunity with one of the largest banks in Europe, and we all got very excited, and we rushed to embrace this new business opportunity and show how our technology would solve all of their problems. Now the customer was showing up, and they had a long formal document with all their requirements. That's usually already not a good sign. And
Yep.
and long story short, the scale of what they probably wanted to solve was about 20 times larger than anything we had tested our technology with at that time. Now, I'm happy to say today, looking back on that moment, it would probably be a piece of cake today. I think the volume, the scale of the problem is small compared to what we can handle today. But back then, when the technology was new, it was about 20 times larger than anything we had tried, and they had very specific requirements on how fast transactions had to be processed and so
Yep.
on. And we rallied the whole team around this, and we put months of effort, months of calendar time with a large engineering team. And it was just to be completely candid, it was a dismal failure. A dismal failure. The technology wasn't ready for that, and just the long hours, people working 12, 14, 16 hours a day to try to make it work, and it was so beyond reach. So we obviously lost the business. We didn't win that account, but much more heartbreaking than that was just the emotional grief of the whole team pushing themselves 16 hours a day for just such a disastrous failure. We were really nowhere near the goal at the time. But there were some important lessons learned in that, which is the most important of which is don't take on. You need to know yourself. You need to know your technology. Just as a person you shouldn't run a marathon if you've never run 5K, right? Uh,
Yeah.
Similarly, don't try to use your technology in an environment that's like 20 times larger than anything you've ever tested it on. The odds of success are approximately zero. So there was a big lesson in that for me and for the team. And following that, we were much more careful in the engagements that we did with customers. That was one that
Yes.
was memorable for me, and a lot of emotional grief went into it, and the team went through the ringer as a result.
Yeah, I'm sure it did. Yes. So we'll move on to maybe a slightly happier topic. So, can you tell us about your career highlights so far?
Okay, sure. Maybe I'll touch on one or two. So, I mean, right now I'm CTO for AI strategy, which is very exciting. And before that, I was CTO for data for the previous few years. And I had the privilege of being a founder of several exciting new technologies. I really have, when I look back on my career, those moments where I was the founder of a technology, and particularly the ones that went on to good commercial success, earning hundreds of millions of dollars. I had a few. Not They didn't earn me hundreds of millions of dollars. They earned the company hundreds of millions of dollars. I'm just a salaried employee, but nevertheless, to see as an engineer, to see your work come to fruition and be successful in that way, and actually help customers is it's extremely powerful and enjoyable. So in my previous job, we founded the next generation data warehousing technology, which was very exciting. We founded the IBM's first data virtualization technologies to do globally distributed heterogeneous analytic queries, which is very exciting. And before that, I was another highlight would have been the work I did around autonomic computing, which is in the domain of systems that manage themselves. We never fully created systems that fully manage themselves, but we were able to move the bar considerably in the realm of database systems that I was working in, and I had a lot of fun with that. And all of those cases, by the way, just going back to the previous question of the tip that I gave earlier around building a prototype, showing a demo, all of those cases where I had the privilege of being a founder inside of IBM with some new technology. And by the way, very often it wasn't just me alone, it was with colleagues. We do these things as a team. But in all those cases, whether it was me personally or a small team of us with IBM researchers collaborating with me, in all those cases, we followed that tip of scrambling to get a demo working so that the decision makers who were going to decide to fund something could really see it in action. So anyway, those are a few of the highlights, and yeah, I've been very fortunate to have those opportunities for sure.
Good. Okay. Sam, can you tell us what excites you about the future of the IT industry and careers in IT?
Well, I think that, somewhat amazingly, it's just going to keep expanding and accelerating. I mean, that on its own is exciting. There's very few industries where we have that kind of confidence. And that expansion over the next 20 years is going to be fueled in part and maybe primarily by the advent of artificial intelligence, as we talked about earlier. That's one of the reasons why I'm so excited about my current job in AI strategy. And this whole paradigm shift of programming by instruction to a new paradigm of programming computers by showing them examples. Such a fundamental change. And we're going to be able to program computers in this new paradigm in ways that were just completely impossible in the previous 50 years. So computers are going to do things. It's going to be breathtaking what computers can do. I mean, we're already seeing computers. I mean, if you think about just 15 years ago or 20 years ago, it was impossible for a computer to beat a chess grandmaster, right? Until 1997, that's a little over 20 years ago, 23 years ago, 1997, when Deep Blue was able to beat Garry Kasparov in chess. But even that was done mostly with horsepower. Just brute force. Today, the best chess playing programs in the world are driven by AI, and they are dramatically better than Deep Blue ever was, and with a tiny fraction of the processing power, because they've been trained differently. They've been trained by example using artificial intelligence, neural networks, reinforcement learning techniques. But that's just one tiny example in the realm of play. Self-driving cars will be fueled by AI and so on. Medical treatments, fraud detection for banks. There's this almost endless list. Every single business domain is going to be upended by this incredible power of computers that have been programmed by example, not by instruction. It's going to change society very dramatically over the next 20 years. So I think we should all be optimistic about that. I know all these technologies, like everything in life, they can be used for good or bad. And people tend to worry about the bad. But so far, if you look around the world, so far technology has helped us more than it's hurt us. I think most of us are happier we're living today than 300 years ago, for example. So I think we should be optimistic about these coming changes. I think they will lead mostly to goodness, mostly to a better society, and very exciting future.
Yes. I mean, as you were talking then, and you obviously mentioned the fact that sort of 15, 20 years there's been significant difference, and you obviously mentioned the social implications as well. Do you think that's going to be the same sort of impact over the next 15 to 20 years? I mean, if you look back to, I suppose, when smart technology in particular sort of became prevalent, there's been such a shift in the way we lead our lives as a result of that. Do you see that continuing?
Yeah, I think it's going to continue and accelerate. But one of the things that's different today than it was maybe 20 years ago is that 20 years ago, when we had these changes, they all seemed very harsh. It was like you had to learn something. You had to sort of embrace a new technology, a new way of doing things. If you think about the changes that we have in our society today, they're much more natural to us. As an example, you log on to Netflix, it's very natural. You don't feel like you have to be a computer programmer. You don't have to learn a whole bunch of new technology. You just go to a website, click, 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 and you're watching movies. Similarly, with ride sharing, for example, you download an app and now you can start using Uber or Lyft, that kind of thing. But if you think about the change in society, that these simple apps that come to us so naturally, what that really means, it's very profound. Movies, blockbuster movies where you don't have to show up to a movie theater. Taxi companies that have no taxis. It's wild. It's absolutely wild. And so it feels like these changes are accelerating, but they're accelerating in ways that are more natural to us. It's somehow, I don't know if that's we've reached a tipping point in the technology that we're simply able to make it more natural, or it's a realization on the part of engineering companies that they realize they need to make their technologies more natural. Probably a combination, but it is more natural. It's just somehow it's like everyone can do it, and so these changes are going to come fast and furious. They're going to accelerate, but they're going to come to us in very natural ways that it's not so hard to adopt, which of course in turn just fuels the acceleration of the adoption.
It does. Yeah, no, very much so. Okay, we're going to go into the reveal round now. We're going to find out a little bit more about you and the way you think. You ready for this?
Okay, sure. Let's do it.
So what first attracted you to a career in IT?
I started with computers when I was in, actually, even before I took any formal courses in high school. A relative of mine had a home built computer. Very few people had computers in those days. It was the early 1980s. And I began teaching myself programming, and I was pretty much hooked. I was hooked from then on. I would also say I'm not sure I'm really qualified or cut out to do much else. It seemed a natural career choice for me. I really never aspired to be a doctor or a lawyer or a business owner or those sorts of things. I was always attracted to science and engineering.
What is the best career advice you've ever received?
There's I've had the benefit of having a lot of great mentors, and maybe a corollary is that it's very important to have good mentors. But aside from that, best career advice I would say is to realize that you're working with people. Everything you do, there are people involved. It's very important to get along with people, to inspire people, to collaborate with people, to not upset other people. And that's true in multiple dimensions. First of all, usually you can't get done what you need to get done if you're an army of one. And this is one of the big changes, by the way, when you pivot from school to work. When you're in school, schools want you to work alone. If you start copying off of other people, it's called cheating. But in the workforce, it's exactly the opposite. It's all about collaboration. And if you try to work alone, it's a negative. So one element of this is you got to get along with people because you need to work as a team. You need to get along. But there's a more strategic thought in this, which is in the future, you're probably going to depend on some of these people. Some of these people may work for you in the future, or some of these people may be your boss in the future. And nobody can predict, those vectors. Nobody can predict. You cannot predict today where these people are going to be in 5 years, 10 years. So you should always operate on the assumption that one day this person could be your boss or your employee, or you may have some fundamental dependence on them. And it's really important to make sure you're getting along and building these relationships, not burning bridges. That's true in any industry, but I think in engineering, in the engineering fields, we work as teams. That's the nature of the business. So it's this social dynamic is super important, and maybe not always front of mind for engineers who are, always thinking about the technology before they think about people. I shouldn't say always, but sometimes thinking about the technology before they think about people. So, um, yeah, I would say put the people first.
Okay, and maybe a slightly more difficult question. What is the worst career advice you've ever received?
I remember I had a manager once early in my career, and I suggested to him some project I wanted to work on the side. I don't remember what it was. It was so long ago. But I remember he said to me, actually, he wasn't the manager. He was the team leader. Okay, he was a team leader, and there's another guy who was the manager. And the team leader said to me, "Yeah, that's a good idea, but right now we're in a crisis. Right now we've got this crisis and this deadline, and so I would suggest," he said to me, "I would suggest to you, Sam, that put that on the back burner for now and come back to it after this crisis is over, and maybe 2-3 months from now, you can take a look at that." A few days later, I met with the guy who was the actual manager, not the team leader, but the actual manager. And I mentioned to him I had this side project, and he said, "Oh, that's a good idea. You should go do that." And I said, "Well, thank you for the support, but the team leaders mentioned we've got this crisis going on. We're all heads down on this initiative or whatever, some deadline. He suggested I wait 2-3 months, which I don't mind doing." And the manager turned to me and he said, "Don't listen to that guy. That's the worst advice you'll ever get." Which, as a junior engineer, was surprising to me. I wasn't expecting that. And the manager turned to me and he said the following great, great words of advice. He said, "There's always a crisis. If you wait for the time when there's no crisis, you'll be waiting forever." So just find a way to get it done. Do it on your own time. Do it on the weekend. Do it on the evenings. But if there's something you want to do, within reason, obviously, he was not suggesting that I drop my day job, obviously, but if I want to spend an hour or two on my own time or whatever per week, just get it done, because there's always going to be some crisis. And yeah, so I thought, the advice, it turns out in retrospect, the advice to not work on something because there's a crisis going on was, really naive advice. I would not recommend that advice to anybody.
No, I think you're right. Absolutely. Okay. If you were to begin your career again in today's world, what would you do?
Wow. Okay. What would I do differently? Or the same, I guess. I think, I look back on my career. I started my education in electrical engineering and then later did a master's in computer science. I would say now I regret that. I wish I had started with a bachelor's in computer science. It would have served me well. I would have enjoyed it, and it would have helped me in my career. Of course, hindsight's 2020. I didn't know that at the time. Yeah, I would say it's also really important to get into the habit of continuous learning, especially in high tech, especially in software engineering, because everything is changing all the time, and the rate of change is just going to keep accelerating. So, whatever programming language it'll be around for a few years, but it'll probably fade over time. There'll be some hot new language, there'll be some hot new data format, there'll be hot new technologies. It's really important to get into this habit early in your career of being constantly staying up to date and learning new things.
Yeah, that's very true. I think everything tends to have a shelf life, particularly in this industry. And what career objectives are you currently focusing on yourself?
Well, I have that's an interesting question. It would have been a more interesting question perhaps a few years ago. At this point, I'm the CTO and an IBM Fellow, and strictly speaking, at IBM, there are no possible promotions for me on the technical track. I've gone all the way, which is an interesting luxury. So I don't have necessarily career aspirations in terms of being promoted. My aspirations now are entirely about the technologies I work on and what value I can try to bring to the world and to our customers to make the world a better place. And so I'd say right now those are mostly in the realm of AI. As you know, I'm working on AI strategy. And the interesting thing about AI today is that all the hype in the news is around the very dramatic demos, but The dramatic demos that you see are, they're mostly magic shows in the sense that they're carefully curated and they're not really as intelligent as they seem. It's not that hard to pull off the illusion. The vast majority of machine learning and AI that's actually being used in the world in actual business applications is in the realm of pretty simple algorithms. Not all, by the way, but not all. But probably more than 50% are linear regression and logistic regression, and probably more than 75% are on structured and semi-structured data or text. Which is, and the reason I mention that is that so much of the hype, so much of what you see in the news and even in the scientific literature is around image and video and robotics, all these very visual, exciting things, right? So there's this huge difference between where the money's really being made on, numeric processing with logistic regression and linear regression and other methods as well. And it's not only those things, but gradient boosting methods are very popular and so on. And there are applications of neural networks, but they're in the minority. And so I would say one of the goals I have is to help us as a company, the IBM Corporation, and also as an industry and as a global community, to see how far we can go to pivoting from the relatively still simple applications of machine learning and AI to get to much more sophisticated approaches and applications that will help transform the world.
Okay. And Sam, can you tell us what the number one non-technical skill is that's helped you in your career so far?
Oh, by far, by far, it's communication. The ability to speak and write with clarity, to be able to inspire people, to help people understand quickly. There's no question, and it's I would go so far to say as they shouldn't let engineers graduate without some training in public speaking and technical writing. And people often ask me in my career, what are my tips for public speaking and so on. The number one tip I would give people is spend some time, if you haven't been trained in it formally and you don't have the time to take a course or something, just spend some time on YouTube and watch some people who are really good public speakers. And how do you know who they are? Well, if they capture your attention, that's really all that matters. So find some people who capture your attention on YouTube. Sometimes famous politicians are pretty good at it. That's how they got to where they are, or one of the ways they got to where they are, right? So find some politicians who are really good, or some motivational speakers or scientists who are really good. TED Talks. You can often find some great speakers on TED. And just spend some time with those videos. And instead of listening to the videos for the content, just study what is it the speaker's doing that's capturing your attention. Did they start with a joke? Are they enthusiastic? What they do with their hands? All these little things. Just study it, watch them, and you can learn a tremendous amount. And you can become actually quite a skilled public speaker just by watching a few YouTube or videos or TED Talks of people who are really good at it.
Yeah, agreed, definitely. And Sam, what do you do to keep your own career energized?
Well, I've done a few things over the years. First of all, it's important to work on things you're excited about and are important. The way I've managed to do that in my career is I've brought ideas forward to the executive team, to the decision makers, and I said, here's what I think we should work on. And I've been fortunate that at least a few times they listened to me and gave me a chance. It's important to have people who will give you a chance, and it's also important to tell them what you want to work on, and ideally bring your own ideas forward. If you don't do that, then what will happen is they'll decide for you. They'll just give you whatever problem is needs attention, and it may not be so interesting to you. It may not be the most important problem that the organization has. So you're much better off being proactive and suggesting what you want to work on. So that has served me. I also spend a lot of time every week, and it's grown as my career has changed, but it's something I always did. I always spend time every week learning new things, and not only things that are directly in the domain of what I'm working on, but often studying things that are in nearby adjacent areas. And in surprising ways, there are synergies that pop up. So, for example, if you're working in automation, it may not be obvious that you can learn something from the economists, but actually economists spend a lot of time studying the trade-offs between things. That's what economics is all about. It's about trade-offs. And trade-offs are a huge part of automation. When you decide to do A instead of deciding to do B, or should I do A now and B later, or B first? All these things have trade-offs. So just as a bizarre example, we don't really think of economics as being something that computer scientists should study, but actually there's a lot you can learn. That's just one silly example or minor example, but learn things, spend time, carve out deliberate time, block your calendar if you have to so nobody interrupts you, make time to learn. And I would say, especially if you're in the technical path, part of that learning time should be actual programming. Make sure that you stay at the keyboard writing code, because if it's harder to do as your career evolves. You climb some kind of a corporate ladder. It's usually the case that people move away doing from the majority of their time on code to less of their time on code.
It is exactly true. Yeah. And Sam, what do you do away from technology in your spare time?
Well, I got a few hobbies. I would say some of my hobbies are typical hobbies. I ride my bicycle. I like to watch movies. I sometimes read books, fiction novels. But maybe I play the guitar as well, which I enjoy. But probably my most unusual hobby, which is my main hobby, is I'm a fencer. And I like to fight with I fight with swords. So so the backdrop is when I was a teenager, I got into fencing competitively, and I was a nationally carded athlete at the time. And then when I got into my early 20s, I dropped it, and I really didn't touch it for about 30 years. And just a few years ago, I got back into it, and I'm really enjoying it. So the last 3-4 years, I'm picking it up again.
Wow, that's something that hasn't come up before, I must admit.
There you go, something new. Okay, it's a lot of fun. I recommend it. Anybody wants to try a new, interesting sport, it's a fun combination of fitness and tactics and technique, and it's got something for everybody. So.
Sam, can you share a parting piece of career advice with the IT Career Energizer audience?
Yeah, I would say the parting advice. Be deliberate in your career. Be deliberate on what you want to achieve. Wherever you want to go, if you don't know where you want to go, you are extremely unlikely to arrive there. So be deliberate, have a vision of what you want to accomplish, and you can, over the course of your career, you can adjust it, tweak it, change it, but it's always good to have that mental vision of what you're trying to achieve. And you'll be far more successful if you have that mental model crisp in your mind.
Yes.
Work towards it.
Indeed. Just having that sort of guiding light or sort of long-term goal.
Yeah. People often say, where do you want to be in 5 years? I actually don't think that's robust enough. People should think really strategically, like when you retire, in 30 years or whatever, what do you want to look back on and have accomplished? That's, I think, a more profound way to think about it.
And finally, Sam, what's the best way we can find out more about you and connect with you?
People can connect with me on LinkedIn, Sam Lightstone. I think I'm the only Sam Lightstone at IBM. There's one other guy with the same name. He's not at IBM. So Sam Lightstone at IBM. And also on Twitter. My Twitter handle is Sam Lightstone, one word. And I'd love to see people join me there.
Sam, thank you so much for joining me on the podcast today. It's been great chatting with you.
Wonderful. Thanks for having me, Phil. It's been a lot of fun. Thank you.
Hi, Phil here again. Now, if you thought about being a guest on a show yourself, or you have somebody in mind that might be a good guest, please do let me know. You can reach me on Twitter, where I'm at PhilTechCareer, or you can find me on LinkedIn, or you can even contact me through the website, which is itcareerenergizer.com. Thanks again for listening, and have a great week.
Thanks for listening to the IT Career Energizer podcast. To find out more about building a successful career in IT, visit itcareerenergizer.com.